Hi everyone, it's Learn with Ceri. Well done on completing Quest 4. I'm going to have a look at some of the questions with you and hopefully give you a couple more ideas. We're going to look at question 2, question 5, question 8 and question 10 today. Let's have a look at the super even question. I don't know if you remember this one. Call an even number super even if the sum of its digits is an even number. For example, 24 is super even because 2 plus 4 is 6, but 14 is not super even because 1 plus 4 is 5, which is odd. What is the smallest 3-digit number that is super even? Okay, well the smallest 3-digit number is 100. So when we add the digits, the sum of the digits, so we've got to add 1 plus 0 plus 0, well that is odd, so that's no good. And this number is going to be even because it's got to be even in order to be super even. So because the 1 and the 0 make 1, adding on an even number will always be odd. So anything starting 1, 0 straight away is going to be no good. So let's go to the next tens and let's try. Let's see 110. Does that any good? 110. 1 plus 1 plus 0. 1 plus 1 is 2. Oh, there we go. So 110 is even. The digits add up to an even number. So 110 is our first super even value in the 3-digit numbers. There you go. It is always nice if you can find a slightly quicker way. So for example, I didn't bother trying 102, 104, 106 or 108 because I knew that the 1 plus the 0 added on to an even number would be odd. And then the first one was going to be 110. Okay, let's see what else we've got. Let's have a look at question 5. In the diagram below, B is the midpoint of AC, and polygons XAB and BCDEY are regular. What is the measure of angle BXY in degrees? Well, regular is telling us that the triangle is an equilateral triangle, because regular means that all the angles and side lengths are the same. But because we've got B being the midpoint of AC, then the fact that the pentagon is regular as well tells us that the yellow highlighted lines there and the green highlighted lines are equal. So this tiny triangle in the middle here, where X and Y have been connected, is isosceles, because the fact they're regular and B is a midpoint means that these lengths, the lengths on the pentagon, are the same as the lengths on the equilateral triangle. There's nothing that special about this vertex here, like it's not on a line, it's not completely at a point. We know that the angle at X there, AXB, is 60 because it's in an equilateral triangle, but that doesn't really help us. So it's going to be the fact that that it's an isosceles triangle that's going to help us solve this problem, and we're going to need this little very acute looking angle here in order to then solve the other two angles in the isosceles triangle. So let's have a look at that. The equilateral triangle angle is 60 there, and the angle ABC is 180 because it's on a straight line. You might know the interior angle of a regular pentagon, but in case you don't, there is a nice neat rule for the angles in any regular polygon. The easiest way to think of, well, this happens to be a pentagon, but this works for all regular polygons, is that the exterior angles always total 360. So if you've got 5 exterior angles making 360, then the exterior angle will be 360 divided by 5, which is double of 36, which is 72. So the exterior angle of 72 and you can use that rule to work out the interior angle as 108. We could do it that way and put 108 here, but actually I'm going to just use the fact that this exterior angle here is 72, because then I know that the tiny angle, I'm going to have to use notation here, x to b to y, is 72, take off the 60, so that's 12. And if we know that this angle is 12, then these two angles here have to be equal and total 180. So if we do 180 take away 12 and then divide it by 2, we get our answer. And so if we subtract that, we get 168 divided by 2. And so the answer we're looking for the angle BXY, BXY, is 84 degrees. Okay, guys. So a couple of extra tips there for you about regular polygons. Some algebra in this one. X plus 2y equals 9 and 5x plus 4y equals negative 4. Then what is the value of 8x plus 10y? So we need to use these two statements that we know are true facts to try and alter them, manipulate them until we've got the value of 8x and 10y. And 5x plus 4y is closer. If we doubled it, then we'd get 10x plus 8y, and that's the wrong way round for our coefficients. If we multiply this one by 3, so we get 3x plus 6y equals 27. And add that on, we've got our 8x. And actually, that's a bit of luck. If we do 4y from here, added to the 6y here, then we get 10y. So that's what we're going to do. We're going to take 3 of the first equation and add it to 1 of the second equation. Just write the second equation underneath the first there. Add them together. We've got 8x plus 10y, and the value of this, 27 plus negative 4, is going to be our solution. There we go. Happy days, 23. Okay? There were other ways to solve it, but I think that was probably the most efficient. Did you get 23? I hope so. Okay, on this question, the diagram below, AB is parallel to FG. So we know that BCD is 20 degrees and DEF is 70 degrees, and they're labelled for us. We need to work out the obtuse angle CDE in degrees. Now, I've seen quite a lot of these in my time, so I know that a really good method is to put an extra parallel line on, and then you can use your angles and parallel lines rules. So we can say that this angle over here is 20 degrees because it's an alternate angle in the parallel line. So we've got that little green bit there, we can write 20 degrees there. And similarly on the other side, here we've got co-interior angles. So if this angle here is 70, then the portion below it is going to be 110 degrees. And so the obtuse angle CDE is 20 plus 110, which is 130 degrees. So with that extra red line, made it quite quick to solve. So I hope that's useful for future for you. So all that's left is to wish you loads of luck for the final quest on stage 1 next week. Go for it. I hope you do really well. Bye bye.